Fourth generation languages take away the idea that you have to reason about how the computing is done and focus more on specifying what you want out of a given computation and then letting the computer figure out the problem of how to actually generate that result based on the inputs that it has to deal with.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the Geospatial community. My guest on the show today is Paul Ramsey. So Paul Ramsey is the co-founder of a extension for the Postgres database called PostGIS. So this adds a whole bunch of spatial functionality to the Postgres database. He's been on the show before. Last time we were talking about vector tiles and how we can generate them directly from a Postgres database. This time around we're going to be talking about SQL, so the standard querying language. And my hope is to shed a bit of light on what it is as a language and why we should be thinking about using this or learning this in terms of geospatial. Towards the end of the conversation, we move on off from SQL and talk about relational databases in general. And because of Paul's deep involvement with the Postgres and PostGIS extension, we relate SQL back to that environment. And we talk about what you get when you get a Postgres, PostGIS database. Before we get into the conversation today, I want to tell you about PlaceKey. So this is interesting. PlaceKey is not an organization as such. It's not a company. It's not a service. It's, at the moment anyway, it's just an idea. And the idea is to create a unique identifier for every geographic area in the world. So there's about 500 organizations and businesses supporting this idea, supporting the concept of creating this unique identifier. And they're hoping to create a new industry standard around it. So what is PlaceKey? There's a lot of sort of mystery at the moment about how this is going to be actually implemented, but the idea here again is this universal place ID that standardizes physical places, so data from different data sources can be more easily shared, matched, and located. And I guess the promise here is less time cleaning data, more time innovating, more time solving the world's problems. If this sounds like something that you would like to be involved in or want to find out more about, go to placekey.io. Welcome back to the podcast, Paul. Thanks for doing this with me. You did a fantastic job last time you were on, and that episode we did around vector tiles and PostGIS was really, really well received by the community, and I'm really pleased that I could have you back on again. So today we're going to be talking about SQL, Spatial SQL, or SQL, as some people call it. And the reason for this is I feel like relational databases are kind of the unsung heroes of the geospatial world. So it's wonderful to have you on here and to shed a little bit of light on that. Before we dive into the conversation, perhaps you could just take the time to introduce yourself to the listeners.
Sure. I'm a geospatial database developer, co-founder of the PostGIS spatial database project. I've been working in geospatial for 20 plus years and working as a hands-on programmer in Postgres for a dozen. And currently I am a executive geospatial engineer for Crunchy Data, which is a open source support company around the Postgres ecosystem.
Wonderful. So I'm thinking already we're going to end up relating SQL back to PostGIS, and that's fine. So perhaps we could just get started. What is SQL?
What is SQL? I was introduced to SQL by a colleague who referred to it as SQL, and I found that immensely confusing at the time because he just said, "We'll do it in SQL." And of course, I thought, the second movie of it took a while to figure out, but it really is well described actually by its acronym SQL, Structured Query Language. And it's good to situate it in terms of history of languages. It is a language. It's a query language. It's what computer scientists might call a fourth generation language. And it's worth it to go back and say what the generations of languages are. Like a first generation language was literally writing the ones and zeros. If you see the pictures of people in the 1940s with plug boards connecting wires, between ports on their big room-sized computer. That was someone programming in a first-generation language. Second-generation language just abstracted that so you could write it in simple mnemonics. When people talk about assembly languages, those are second-generation languages. Almost all the languages we work in today would be fairly categorized as third generation languages. So they've abstracted away from the machine, have common idea of variables and loops and branching structures. Fourth generation languages take away the idea that you have to reason about how the computing is done and focus more on specifying what you want out of a given computation and then letting the computer figure out the problem of how to actually generate that result based on the inputs that it has to deal with. So SQL is often harder for people to get into sometimes who have had previous experience with third generation languages because they're used to thinking in terms of iterators and branching structures. Whereas in SQL, you kind of have to step back and let the computer do the work. You define what you want in terms of, I want these columns, I want them only when this condition applies. I want them to match up to this other set of columns, but only when this condition applies. And let the computer figure out what the right order of iterating on different rows in those columns and what indexes to use to join things up. And even the existence of indexes, these are all delegated away from you as the query writer and handed to the computer to figure out how to do most effectively. So SQL is a standardized version of a query language. Prior to SQL, pretty much every relational database had its own query language. Oracle was the first big proponent of SQL as a standard. Other database companies quickly rushed along. It became sort of gelled as the language you use for doing queries against relational databases in, I'm just going to totally guess, in the mid 80s, early 80s. And it's been with us ever since. So it's a very old language as languages go. Most people are using languages which postdate SQL, which is quite something because it's still just as relevant today as it was back when it was invented, which is not something you could say about COBOL or Fortran, which are languages which were in their prime when SQL was invented.
So yeah, that's really interesting that you point that out, that it is an older language and it's still here and it's still working. Is there a hint to why it's been so successful in the name, in the structured bit or in the standard bit of the SQL? Because it's been implemented across a range of different relational databases?
I would guess it has to do with the importance of data in any real system and with the sort of underlying flexibility and long-term utility of the relational model. The relational model was itself, invented as a concept back in the mid 60s and didn't really become an effective thing until computing caught up with it in the late 70s. But that model of relations, of collections of rows and columns that you can reason with logically, turned out to be incredibly powerful, incredibly well suited to the kinds of problems we solve with computers and sort of the standard problems we solve with computers, business problems, all kinds of data problems. It took a long time, again, for computing to catch up with the harder problems, things like neural networks and graphs and so on, which don't map to the relational model. But it's shocking the amount of domains you can map into a relational model cleanly and even efficiently. And I think because the model was so flexible, the language on top of that model, once it was standardized, ended up just going along for the ride. And it remains such a useful way of expressing the idea of here's a subset and relationship between different data sets and I want this result, that it's been bolted on top of things which aren't relational databases. So if you're in the big data space working with a Hadoop, you might be writing your queries in, I believe it's Hive, which is a SQL engine which just converts the SQL into Hadoop processing commands in much the same way that under the covers, the SQL engine in Postgres produces an execution tree.
So we've got this domain-specific programming language, and you mentioned at the start that it is a programming language, not just a querying language. It's been incredibly successful throughout the years because we can map so much of our data to this relational structure that you were talking about before. So in terms of geospatial, should we be learning this? I mean, because I think that there's so many interfaces now to relational databases. And I guess if you're working in an organization or working on a project, eventually you'll sort of migrate away from flat files once your data starts to grow in size and volume, and you'll want to put it in a relational database. And there's so many other ways of getting at this. We can use Python, we can use R, we can use something like QGIS, for example. Should we bother learning SQL?
There is no doubt that if you want your career to progress beyond sort of abstractions which are provided to you by some other programmer, you're going to want to learn SQL. It's one of the core pieces of IT knowledge that's very hard to avoid, precisely because, as you said, in any enterprise of larger than a certain size, the important data is going to be stored in a relational database. And while there are interfaces that allow you to browse that data, you're not going to be able to query it effectively or efficiently unless you can send those queries to the database to execute locally against the data.
Okay, so that makes perfect sense. Like we talk about efficiency there, and obviously the closer we are to the machine, the closer we are to the database, the faster, the more efficient those queries are going to be. But I guess what I'm wondering here is that do you see a time where we will be able to replace this with anything else? Will R, will Python, will something similar sort of take over? Will we be able to get to that same state of efficiency with another language?
We can only insofar as the data migrates away from the database to some other store which is implemented in that language. I mean, what's happening when you're using R or Python and pulling data out of a database is that R or Python is writing SQL behind the covers and executing that SQL in the database and pulling the result back into the R or Python execution environment. And then you do your extra work there. The reason why there's efficiency in pushing things back to SQL is you can cut down the amount of data which is being pulled out of the database. The reductio ad absurdum is I've got Python and I say load table and it slurps the whole table into Python. And then I do a whole bunch of things with that big in-memory table. And then when I'm done, I say save table and it stuffs all the results back into the database. If the work you're doing in Python doesn't involve anything more sophisticated than the things you can do in SQL, then you almost certainly have a radically less efficient implementation by doing it quote unquote in Python, because you're using the database as nothing more than a file system layer. And the same is true of R, and the same is true of really any language attaching to the database. The database has huge advantages in execution of having its execution layer sitting right next to the storage layer. You can write native Python and R tools that do that, but you have to bear in mind that what you're doing as you make your query environment in R and Python more and more sophisticated is slowly writing a relational database in R or Python.
Yeah, which seems like a complete waste of time. So we've established this as a really useful language, right? It's incredibly efficient when we're dealing with relational databases. It's a standard language we can use at other places. And it seems like a really great skill to learn. We have data lots of places, so why not learn how to use it, how to manipulate it directly? What does this look like for spatial? So in terms of the PostGIS, so this is an extension for the people that don't know to the Postgres database, and it adds the spatial functionality of that. What kinds of things, or maybe perhaps a better question is, what kinds of things can't we do with spatial SQL in something like PostGIS?
I think the main thing missing from the point of view of a geospatial practitioner from Spatial SQL is just the ability to see the answers. Visualization is a huge part of exploratory data analysis, and exploratory analysis is a big part of what geospatial professionals do. So particularly in the early stages of a project, the thing that folks will do a lot is poke around at the data, and you can do that in Spatial SQL. Not being able to see things is a huge drawback. I find when I'm doing exploratory work, I always end up in QGIS looking at different chloropleth maps, maybe running some analyses in SQL and pulling those back into the visualization environment. You see the same thing with R. R would be a terrible language for doing statistical analysis if you couldn't plot the results. I mean, you could run regressions, but if you can't plot the residual plot afterwards, it's going to be really hard to figure out what's going on. And the same thing is true in the geospatial world. If you can't plot a map of the result, it's going to be kind of hard to reason about what's going on and take the next steps. So sad. That's the main sort of missing piece. I don't know if it's a missing piece so much as it's just the fact that databases always form one component of a whole solution. Rarely are they the whole solution in and of themselves.
So that's really interesting, because that kind of means, at least for someone like me, that kind of means that most other stuff in terms of spatial we can do in an SQL in a relational database. Would that be a fair statement?
I would think it's a correct way. I like to talk about PostGIS as GIS without the GIS, because you think about the questions that you ask analytically of a GIS. It's usually something along the lines of, given this layer, summarize values from this other layer with respect to the geometries in the primary layer. So really the classic ones, spatial join, I think they called it, or oh, I can't remember the name of it in ArcView, but Esri has its term of art. Every GIS company has their term of art for putting together two layers on the basis of a spatial relationship. And that's the core idea of a database. It's a join. And when you have spatial functions, you can do that join based on spatial conditions. So it's a spatial join. And then all the other things you do once you get that join, chop up the results based on intersections or overlaps, or take objects which are similar in one attribute and melt them together using a union, find the nearest X to Y for every Y. These are GIS questions. And in the GIS, the final step might be, and then put it on the map. But the core engine of a GIS system basically is analogous directly to what the core engine of a spatial database with a suitable set of spatial functions provides. And, as the spatial database with the most functions, I can say with a certain lack of humility that PostGIS is the best engine you could use to do your spatial analyses.
Okay, so it sounds like we could replace a whole bunch of tools in our stack then if we had to choose two tools to go out and be GIS geospatial practitioners. Perhaps two great tools in terms of open source ones anyway would be PostGIS and something like QGIS for visualization. Could you give us an idea of, you mentioned a whole bunch of spatial functionalities. How many are there?
Well, you get into the problem of counting. There are 700 functions defined in PostGIS, but many of those are duplicates of similar functionality with slightly different signatures. Some of them are backing index methods, so not really of interest to the end user. I'd say in terms of analytical functions, which you actually use to do stuff with, a couple hundred at this point.
Okay, and can I extend those? Let's say I'm an amazing programmer. Is there a language I can use to extend those functions? Can I write my own functionality into the database?
Yeah, you can. And you can choose your language. Postgres supports Python and TCL and R and pretty much every quote unquote scripting language. The most effective and inbuilt language is a language called PGSQL, which is analogous to Oracle's PL SQL. And people have built really incredibly complex pieces of functionality in PL SQL, some of which you think, really? That's a user contributed one. The concave hull implementation in PostGIS was contributed by a power user and written entirely using PostGIS core functions and PLPGSQL. So you can write really complex, sophisticated stuff in PLPGSQL using the base functions of PostGIS.
Okay, so I can extend it. I can create my own functions using some of these different languages that you talked about. Can I schedule tasks in the database? And I guess another question I have, I realize this is two in one here, but is it possible to execute functions outside of the database?
So in terms of scheduling, yes, there is an extension to Postgres called pgcron that lets you do inside the database scheduling. Obviously, you can also just have a SQL script that you run using an external scheduler. That's sort of the most common one, is to write your logic in SQL outside the database, knowing that all the processing is going to happen inside the database, and turn it over with some external scripting language. So you end up with a 5-line Python script which just says, step 1, connect to the database. Step 2, run this query. Step 3, take the results and save them somewhere else, and run that at some regular interval. So in terms of running functions outside the database, that's basically the way you end up doing it.
So we've got this amazing language and it has all this functionality, obviously depending on what database you choose to execute it in, we're aware of that. But why do you think then that SQL gets so much less attention than something like Python and R?
I think it's because of the third generation versus fourth generation language thing, quite frankly. It's because people get used to the idea of procedural languages and the idea that this is how we solve problems. I take result sets, sets of rows, and then I iterate on them and figure out the answer in my language, which I understand. And because you don't need to know a lot of SQL to get access to the data in a database, I mean, you just need to know select star from table at the lowest common level. You can build everything you want in your language of choice, external language of choice, and still use the corporate database. So you still feel like you're using the corporate source of truth. You're just doing the work really, really inefficiently from the point of view of execution and calculation, but you're still getting answers. So the bar of entry into SQL is extremely low, and people will often step over that bar and then say, done, I know enough SQL to finish my job. And I think that's one reason why you see sort of the primacy of execution environments like R or Python, or Java or JavaScript or whatever, it takes a while for folks to learn SQL if they're not given a little bit of training or even have someone in their organization who can say, hey, here's how you can do it in SQL and it's 10 times faster. They won't necessarily know. And it's also hard because some of the core, most powerful aspects of SQL are necessarily the hardest to understand if you're used to thinking in an iterative third generation way. Table joins, they're expressed in two lines, but they encompass in the execution engine a great deal of complexity. So the reasoning around that can be hard for people to get to initially. But once they do, they never go back.
So how would we get started then? You mentioned it was difficult to learn because we need to sort of get our head around this different way of thinking, this different approach to data
Yeah.
management. Um, so how do we start? And especially in terms of spatial, is it a good idea to start out with a spatial use case and just sort of throw ourselves into that? Or should we, approach the SQL language as a language and just start with SQL without the spatial bits?
I mean, if people are interested in getting the full power of it, I would tend to say start learning SQL and move on to spatial once you've got the core concepts of SQL down pat, because you don't need the extra complication, particularly when you're learning something abstract like joins. You just need to learn what a join is, what the different types of joins are, and how problems, which you might ordinarily cast as iterations, can be cast as set operations and joins in SQL. And it's 2, 3, 4 days out of your life to work your way through a basic SQL course that'll cover those things. So yeah, start with the core basic parts of SQL because that's in many respects the harder part to get over, and then add in the spatial side.
That's some really good advice because you're kind of narrowing it down. You're not making it too complicated right at the
Yeah,
start, and you're trying to understand the core bit, the core activity that you're trying to achieve.
exactly. And particularly when coming from a geospatial background, you already have the base knowledge of what layers are and how features work and the idea of Tobler's law of near things being related to each other. Just even the concept of joining two layers in a spatial condition is something you get already. It's something which, trying to teach spatial to DBAs, which I've done, then you start in a completely different place. You start by explaining this is GIS, this is a layer. So you're really starting at the spatial side because they already understand the logic of set arithmetic and SQL. For people who already understand geospatial, learning that first is definitely better.
I think we've probably covered this a little bit in the last couple of questions here, but I'm curious to know, is there any sort of typical mistakes you see when people are either executing SQL or learning it?
Classic mistake for geospatial people in particular is reaching for the buffer function when actually they want to reach for a distance radius. Ironically, or not ironically, expectedly, you get the same answers if you cast a solution in terms of make a buffer, then find me the things that touch it, as you do find me the things that are within a distance. But you get those answers at a huge performance penalty. So it's a common one because geospatial people have been trained to verbalize the question of find me all the stuff near this other thing by using the word buffer. So they naturally reach for it as a SQL function, but it's an expensive SQL function. So that ends up being really one of the most common ones that geospatial people provide. Second most common one would be doing unconstrained joins and then filtering them poorly, just because folks haven't figured out joins yet, but that tends to go away with just a little bit of experience.
It sounds like some of those could be avoided, but we also have to have a really deep understanding of what's happening when we push the button.
Yeah, unfortunately, you kind of do. And there's no easy way to get around it because, like I said, you can get the right answer both ways. It's just one of them is fast and one of them isn't. And this is where documentation, a little bit of training, going through the PostGIS workshops can be useful because we try to explain that here's the problem you're trying to solve and here's the efficient way to do it. Thinking in terms of joins is a huge one. I've been working with a colleague at Crunchy who comes from a developer side background. And so we'll still tend to think in terms of iterators and we'll still tend to build SQL thinking in terms not of set composition and filtering, but in terms of passing lists of IDs between different execution frames. And it's just a really hard habit to break.
I wonder if this problem gets even more complicated when we move between environments. So let's say we're used to working in PostGIS and we move over to MS SQL, for example. Do you think we can take some of this understanding with us and say, okay, well, I know this buffer function perhaps isn't the best way
Yeah.
of getting the answer, or do I have to rethink things again and sort of dive into the documentation again?
No, that the world of computational geometry is, it's mathematical and it's shared amongst the environments. So things like the buffer solution are bad ideas in pretty much every environment. And even better, things like learning how to do set reasoning and SQL reasoning transfers cleanly between environments. So if you get good at SQL practicing on PostGIS and Postgres, that goodness will transfer cleanly to SQL Server and Oracle. SQL is maybe underappreciated to the extent that it really is a really portable skill across different enterprises and organizations, because regardless of what they've standardized on, it's almost certainly going to speak SQL, unless you're unlucky and they're standardized on something like MongoDB, in which case you should probably quit or not take the job.
This sounds like some great advice. Let's stay with these NoSQL databases just for a second. So one of the questions I got in from the public, so I announced on Twitter and LinkedIn, hey, I'm going to be talking to Paul Ramsey. What kind of questions would you like to ask him? And I'll try and weave them into the conversation. So I'm not really weaving this one in, it's brute forcing it in. But the question that came in, which I think fits in really well here, and the question is PostGIS threatened by the rise of NoSQL databases?
Curiously, even less than databases in general, because NoSQL databases, they tend to be a little weaker on the analytical side. Certainly, that was the case with early Mongo, and to some extent, still current Mongo. It's just that they're very much focused on document transactions and really pushing against sort of the online transactional processing side of the relational database space, not against the analytical processing side at all. And analytics were sort of bolted on as an afterthought. Oh, you want to do analytics once you've got your data in the system? Okay, well, we'll figure out analytics now. So the extent that people use PostGIS as an analytical engine, I think not really worried at all. To the extent that they're using it within a transactional context, and for sort of like small OLTP queries, you know, maybe. But I think the reality of the NoSQL movement is that whatever perceived advantages those environments had, they've largely filled up the niches they could fill. And there's this continuum of utility between tools. And I feel like the NoSQL databases fit at the far end of that continuum. Like when you have very specific use cases that require these very specific features that NoSQL databases only have, things like being able to handle like unconstrained write load, or very, very easy sharding and clustering, then you use, and you actually have these problems like at scale, then you have no choice but to use the NoSQL database. And the reason why no choice matters is because what you're giving up when you do that is a lot of the ad hoc analytical capabilities that the relational model gets for free baked in. If there's like a Goldilocks chain of, goodness for data management, that the low end, sort of the baby bear, you've got desktop environments like Tableau or ArcGIS or R. They're extremely flexible. You can do all kinds of cool analyses with them. But when it comes time to start putting those analyses into production, stacking them up onto servers is kind of a brittle solution and doesn't work so well. And in the middle, sort of the medium bear, happy times, is the SQL environment with relational tables, which can scale from things which run on your laptop to things which run in huge data centers, from single nodes to multi-nodes, but still giving you the kind of query flexibility that you lack when you move to a NoSQL environment, where you have this fairly stupid data store which can handle really large volumes of throughput or transaction, but require you to write query logic efficiently yourself, which means it's not good for when you're exploring the situation, but maybe only good when you have the data flow nailed down very, very specifically, and you actually have the scaling problem where you need to give up the flexibility in order to handle the scale. So there are places for NoSQL databases. I just feel like 98% of the people don't live in those places.
Thank you very, very much for clarifying that for us. And personally, I think you did an amazing job with that Goldilocks analogy. I think that was brilliant. Well done. So a couple more questions here from the listeners. What is your all-time favorite Postgres or PostGIS function?
My all-time favorite is SD intersects because it is at the core of almost every spatial join. So just from the point of view of I'm doing GIS work, the amount of GIS work you can do just with GIS, SD intersects is insane. But I also love it because at an implementation level, it has layers and layers and layers. And because it gets used so much, we've had this impulse to make it more efficient. And each step of making it more efficient has involved, for my purposes, learning more about the core execution engine in Postgres, doing cool tricks with our internal handling of the objects so that you can very quickly carry out the intersects calculation, particularly within the context of joins. It's been the gift that keeps on giving because it's really, really useful. And it's been this wonderful sort of intellectual journey to learn all the ways we can make it faster and more efficient and how it works in the Postgres environment. And with the next release of PostGIS 3.1 this fall, for certain use cases, but really common ones where you're joining a table of fairly large objects against another table, we've managed to sneak in yet another performance optimization, which will make things faster by 20 to 30 times.
Whoa,
It's going to be radical. Can't wait.
that is amazing. Hey, so we've talked a lot about functionality, and we've talked about all this amazing spatial functionality we have available. And earlier on in the conversation, we talked about the one thing that's really missing that we can't do with a PostGIS database is we can't visualize data. But in terms of spatial functionality, spatial capability, is there anything that's missing today that you would like to see added?
There's a whole bunch of analytical stuff. Like I have a big sort of wish list document that I keep filling in with different analytical functions because I feel like, I keep pushing GIS without the GIS. So that means that I've got to fill in the functional pieces that GIS systems offer that we don't have yet. The one that I personally miss because I keep running into a sort of interesting and attractive analytical cases that require it are surface interpolation. So given a set of points that either have elevations or have measurements on them, either compute a best fit surface for them, or do some sort of kriging so you can have like a statistically valid surface for them. And then once you have that surface, all the things you can do with the surface, drape things on it or generate ISO lines, that kind of stuff. But surface interpolation, I feel like to have that, it opens up this huge panorama of other possible analytical things that people can do. And it's just like that core piece, a lot like intersects, that opens up all sorts of analytical possibilities.
Yeah, absolutely. Have you got any sort of timelines on those kind of things?
I ended up getting distracted. I was going to have that for 3.1, but we've also got a huge rewrite of overlay calculations in the underlying computational geometry engine for PostGIS, and really want to land that in the fall at the same time as 3.1 comes out. So as a result, I haven't been doing fancy new features. So it'll probably be a 3.2 thing, which puts it at about 12 months out.
Thanks very much. That I'm sure a lot of people are looking forward to trying that out when it does get added to PostGIS. Hey, so I think you've done a pretty amazing job talking about SQL. I mean, I think you made a really strong case for why people should learn it, perhaps how they should approach learning SQL as a language. And I think there's a ton of benefits with these, with the language itself, especially in terms of, PostGIS. There's a whole bunch we can do. So I really appreciate you sort of walking us through that. And then, of course, talking about where it's going. So what this might look like in the future, the kinds of functionalities we might be able to expect. And, of course, that speed up that you're talking about. I mean, that it sounds amazing. Sounds like the future is bright.
It is indeed.
I just want to round off the conversation here. And I think a lot of people look to you as a thought leader in the geospatial world, which they should do. And I'm wondering if you could get one message out to the geospatial industry, to the geospatial community, what would it be?
I would very much like the geospatial community to understand that we as a technology community run 5 to 10 years slower than the larger technology community. And we can learn from what they're going through in terms of what we're going to go through. I see both in large companies and small an amazing focus on just the coolest cutting edge technology around turning imagery collection from a we're collecting pixels problem to a we're extracting features and real-time knowledge of the world problem. And that stokes me up to no end because it's technologically super exciting. And yet it is another brick in a technological wall, which we see being built by our counterparts in consumer technology. It's kind of a thing which, as a technology person, you do. You use to pop open your phone and look at your Google Maps and say, "Oh man, Google knows so much about me. That's so scary." Ironic wink. But it's happening in very real, very scary ways in other jurisdictions now, and who knows to what extent in the jurisdiction we live in. You can see it with the case of the Uyghurs in northwestern China. This is a population of 11 million people, a minority of China, but a majority in their region, who are now basically living in an open air prison mediated by technology, which we're 100% familiar with because we live with it every day in our consumer technology, but which has been migrated over and used in a way which the people who invented it and promulgated it back here in the West would rightly consider terrifying. And we're doing really cool stuff. And there is no doubt that really cool stuff will be used in terrifying ways. So we have to think about not necessarily how not to do the really cool stuff, but how also to use the cool knowledge we have to strengthen the civic society institutions we have in our jurisdiction so that it isn't used in terrifying ways to us. And hopefully we can dissuade people in other jurisdictions from using our work in terrifying ways. And that means taking our heads out of the keyboards and out of technology and thinking about the political ramifications of what we're doing and how we can mitigate it. And I recognize that there are no easy solutions to how we mitigate it. But if we don't think about it at all, it's guaranteed we'll do nothing.
Paul, thank you so much for your time. Thank you for your thoughts and thank you for your insights. I've thoroughly enjoyed the conversation and I really appreciate it. Just before I let you go, where can the listeners go if they want to reach out to you personally, if they want to ask questions or continue the conversation?
You can find me on Twitter at pwramsey. You can find me on the web at cleverelephant.ca. And I look forward to hearing from any of your listeners about what I've said today or any questions they have.
Thanks again, Paul. Much appreciated.
Thanks, Daniel.
At the start of this episode, I mentioned PlaceKey, and I said that it wasn't an organization and it's not a business. It's more of an idea at this stage, but the idea is really cool. The idea is to create a new industry standard around the way we join different data sets spatially. So there's a lot of questions at the moment still around the implementation of this, but the concept is being backed by a huge amount of companies and organizations, and it's going to be launched, I think, in October the 7th. If this sounds interesting to you, if you'd like to be involved, if you'd like to find out more, I would encourage you to go along to placekey.io and check it out for yourself. I really hope you enjoyed that conversation with Paul. We had a few technical difficulties during the conversation, which meant that I needed to sort of piece things together a little bit more than I normally do. But Paul was very gracious, very patient, and I hope that we've created something that is useful to a lot of people. So the goal of this episode was to introduce you to SQL, perhaps convince some of you to take up the challenge to learn it, to apply it to your geospatial problems, and to see it as a real skill that is transferable. It doesn't seem to matter which database you're dealing with, this skill will be applicable in terms of geospatial. So right at the end of the conversation with Paul, I asked him if there was one message he could get out to the geospatial industry, to us, to the geospatial community, what would it be? And it seems to me that that message was very strongly that some of the things that we're creating, there's going to be some pretty severe unintended consequences of that technology, of the knowledge that we're building. And Paul points out himself that there's no easy answer to this, but I think his call to action was just that we should think about it, try and sort of propagate those ideas forward into the future and try and imagine where they might end up and what they might be used for. And that's kind of a hard thing to do, right? Because you're left with this idea, what can I do? I'm just one person. I'm just a part of a very, very, very big and complex machine. What can I do? But I wonder if part of the solution here is not around the idea of being an ambassador. So when we're knowledge workers, when we're creating tools, when we're creating and developing technologies, we don't often follow them all the way through their life. So we create some data, we create some information, we create a piece of tech and we put it into the world, and then oftentimes our job stops. We have delivered the deliverable. We don't follow it on. But I wonder if we could change things by simply being ambassadors for the things that we create, by following them through their life journey, by explaining the concepts around them, why we made the decisions we made, by being open about it and helping support other people and supporting the ideas that we create. When we put them into the world, to be there to support them, to help people understand them, and just help guide the way they're used. Now, I realize that sounds a little bit fluffy and there's no real concrete advice there or a concrete way of solving the problems that Paul was alluding to. But those are my thoughts around it. This idea of following a project, following an idea, supporting it, not just abandoning it at the door. And that's it for me. That's it for another episode of the Mapscaping Podcast. My name is Daniel. As always, you are more than welcome to reach out to me on social media if you have any suggestions or ideas of where I could take this podcast in the future, how I can make it better for you, or topics that you would like me to cover. I would love to hear from you. You'll find me on social media. You are welcome to visit our website, mapscaping.com. And if you have not subscribed to the podcast yet, consider doing so. I'll be back again next week with another episode. And if you're subscribed, it'll just automatically show up in your podcast feed. So feel free to do that. Okay, that's it for me. Talk again next week. Bye.